Hello everyone, in this video we shall be discussing about one of the most widely used electronic devices, that is the bridge rectifier. We shall learn about the bridge rectifier's working with and without a filter. Before we start talking about the bridge rectifier, let us understand what a rectifier means. A rectifier is an electronic device that is used to convert AC power to DC power. Among the rectifiers, the bridge rectifier is one of the most efficient rectifier circuit. They are widely used in power supplies that provide necessary DC voltage for the electronic components. We can define bridge rectifier as a type of full wave rectifier that uses 4 or more diodes in a bridge configuration to efficiently convert alternating current to direct current. Let us now talk about the components of a bridge rectifier. First up, we need an AC power source, since the bridge rectifier converts AC to DC. A transformer, however, if stepping up or stepping down of voltage is not required, then the transformer is not needed in the circuit. Diodes. A bridge rectifier requires 4 or more diodes connected in a bridge configuration. And lastly, a load resistor to minimize the output power. Moving on, we are now going to draw the circuit diagram of the bridge rectifier. Here I am using a software called Multism by National Instruments to stimulate the circuit diagram of the bridge rectifier. Let us start by putting the AC power supply. Then we shall put the transformer. Then the full wave bridge diode. We are going to put a full wave bridge diode. And the load resistor. Oh, and also the ground. We now have everything we need to complete the circuit diagram of a bridge rectifier. We have an AC power supply, we have the transformer, a full wave bridge diode, and the load resistor. So let us connect all these components to complete the circuit diagram of the bridge rectifier. First, let us connect the primary coil of the transformer to the AC power supply and the secondary coil of the transformer to the full wave bridge diode. Now let us connect the full wave bridge diode to the resistor and also connect the circuit to the ground. We now have the complete circuit diagram of the bridge rectifier. If you go back to the introduction part of the video, I had said earlier that the transformer in the configuration may be removed from it if stepping up or stepping down of voltage is not required. The main advantage of this bridge circuit configuration is that we do not require an expensive center tape transformer like the ones used in center taped full wave bridge rectifier, thereby reducing its cost and also its size. So now, to study the waveform of this bridge rectifier circuit diagram, we are going to need an oscilloscope. So I'm going to add an oscilloscope to the diagram. So this is an oscilloscope. I'm going to connect this A channel of the oscilloscope to the AC main supply. So this is the input. And I'm going to connect the B channel of this oscilloscope to the load resistor, which is going to give us our DC output. Just to make things more easier to understand, I'm going to change the wire color of the DC output. So let us now stimulate this circuit diagram. This is the oscilloscope window. Let me size the waveform for easier observation. This oscilloscope window is giving us our waveform for this bridge rectifier circuit diagram. As you can see, the AC input of this circuit diagram is in red color, whereas the DC output is in black color. Let us now talk about the working of the bridge rectifier. When the input AC signal is applied across the bridge rectifier, during the positive half cycle, diodes say D1 and D3 are forward biased and it allows electric current, while the diodes D2 and D4 are reverse biased and blocks electric current. In this case, the current flow is from terminal say A to B. During the negative half cycle, diodes D2 and D4 are forward biased and allows electric current, while diodes D1 and D3 are reverse biased and blocks electric current. In this case too, current flow is from terminal A to B. We now know that for both the positive half cycle and the negative half cycle, the direction of current is from terminal A to terminal B. So this is why we only get the DC output in the positive side. We know that the output DC signal with fewer ripples is considered a smooth DC signal. Here we can notice the ripples in the DC output. To reduce these ripples, a filter is needed. A filter may be either a capacitor or an inductor. A capacitor is used in parallel to operate as a filter, as the capacitor blocks DC components and passes the AC components. An inductor is used in series to operate as a filter, as the inductor blocks the AC components and passes the DC components. Here I'm gonna show you the working of a filter as in the capacitor. So now to reduce the ripple in the DC output, I'm going to use a filter as in the capacitor. Here I've taken the capacitor and I'm going to place it parallel to the load resistance. I'm placing it parallel as the capacitor blocks the DC components and passes the AC components. Let us now stimulate this circuit diagram. We now are getting the waveform of the circuit diagram with the capacitor in it. We can see that the height of the ripple in the DC output is reduced with the capacitor in the circuit diagram. When the voltage increases, the capacitor will charge, and when the voltage decreases, the capacitor will discharge. The higher the capacitance of the capacitor, the more it will smoothen the DC output signal. So with this, the discussion comes to an end, but before I end this video, I would like to list out some applications of bridge rectifier. The high AC voltage can be converted into the low DC value with the capable nature of the bridge rectifier. In the modulating radio signals, to detect its amplitude, concept of the bridge rectifier is essential. For electric wielding, it requires a steady supply of DC in polarized manner. This is possible by the full wave rectifying circuit. Because of the efficient nature of the bridge rectifier, it is preferred as a part of various appliances' power supply unit. For powering up of devices like LED or DC motor, this type of rectifier are preferably be used. Thank you for watching till the end.